Okay, so the first problem we have is using the first derivative test to find where the function is increasing and where it's decreasing, and to find the max and the min. So we have the function f of x equals x over 2 plus cosine x on the interval 0 to 2 pi. So the first thing we have to do is find the derivative, which would be 1/2 minus sine x. And now we have to find the critical numbers, so we're going to set it equal to 0. So we have to subtract the 1/2 on both sides. And we have negative sine x equals negative 1/2. So we can divide both sides by -1, and we would get sine x equals 1/2. So the trig values that go with sine x that would equal 1/2 are x equals pi over 6 and x equals 5 pi over 6. And these are our critical numbers. So now we have to build in a chart using these values within our interval. So we're going to plug into our first derivative. And we're going to use the interval 0 to pi over 6, pi over 6 to 5 pi over 6, 5 pi over 6 to 2 pi. So we're plugging into our first derivative, which was 1/2 minus sine x, and a value between 0 and pi over 6 would be pi over 12. A value between pi over 6 and 5 pi over 6 would be pi over 2. And a value between 5 pi over 6 and 2 pi would be pi. And so we're going to plug into our first derivative, and we have 1/2 minus sine of pi over 12. So pi over 12 is half of pi over 6. And pi over 6 is 1/2. So pi over 12 would be about 0.25. So we would have 1/2 minus 0.25, which would give us a positive number. And then if we plug in pi over 2, we would have 1/2 minus sine of pi over 2. And pi over 2 is 1, but we have a negative, so it would be 1/2 minus 1, which would give us a negative number. And then we have 1/2 minus sine of pi, and the value of pi, sine of pi, would be 0. So we'd have 1/2 minus 0, which would give us a positive number. So what this means is that the function here is increasing, and it's decreasing here, and it's increasing here, because the derivative is positive and the negative and the positive. And so now if we draw it here, our function is increasing and then decreasing and then increasing. So since our function is increasing here, decreasing here, and increasing here, it means that in between, on pi over 6, there's a max. So there's a max at x equals pi over 6. And since it's going from decreasing to increasing, that means that there's a min at 5 pi over 6. So now we have to write that f of x is increasing on the interval 0 to pi over 6 and 5 pi over 6 to 2 pi. And f of x is decreasing on the interval pi over 6 to 5 pi over 6. And that's the first derivative test. So now we're going to find where there are points of inflection and where the function is concave up or concave down using the concavity test. So we have the function f of x equals x cubed minus 6x squared plus 12x. And we have to find the first derivative, which would be 3x squared minus 12x plus 12. So now we have to find the second derivative, which would be 6x minus 12. And to find possible POIs, we have to set the second derivative equal to 0. So we would add 12 on both sides. We would have 6x equals 12. So now we'll divide by 6. We get x equals 2. So that's a possible POI. So now we have to build a chart using this possible POI, and we're going to plug into the second derivative. So we would go from negative infinity to 2, and from 2 to positive infinity. So we can just choose any value between the intervals. So I'm going to plug in using negative 10 and positive 10. So if you plug into the second derivative, which is 6x minus 12, you would plug in 6 times negative 10 minus 12. And we would get a negative number. And if I plug in a positive 10, we'd get 6 times 10 minus 12, which would be 60 minus 12, which is a positive number. So that means that between negative infinity to 2, the function is concave down. So it would look like this. And between 2 and positive infinity, the function would be concave up, which looks like this. So now we have to plug into the original function to find the y value for the POI. So we have f of x equals x cubed minus 6x squared plus 12x. And we're going to plug in the 2. So we'd have 2 cubed minus 6 times 2 squared plus 12 times 2. So this would give us 8 minus 2 squared is 4 times 6 is negative 24 plus 24. So our y would be 8, and when we put it together we would see that our POI is at 2, 8. And we see that between negative infinity to 2, our function is concave down, and between 2 to infinity, our function is concave up, and that's the concavity test. So now we're going to find the absolute max and min on a closed interval. We're going to have the function f of x equals negative x squared plus 3x on the interval 0 to 3. So the first thing we have to do is take the first derivative, which would be negative 2x plus 3. So now we have to find the critical number and set it equal to 0. So we'll subtract 3. We'll have negative 2x equals negative 3. Divide by negative 2 on both sides. We'll get x equals 3 over 2. So that's our critical number. And now we're going to build an x, y chart. And we're going to include the endpoints of the function and our critical number. And we're going to plug back into the original function. So f of 0 would be negative 0 squared plus 3 times 0, which would just give us 0. F of 3 over 2 would be negative 3 over 2 squared plus 3 times 3 over 2, which would give us negative 9 over 4 plus 9 over 2. So we have to combine these, but we have to find the common denominator first. So we'll just multiply 9 over 2 by 2 over 2, and we'll get 18 over 4. So we'll have negative 9 over 4 plus 18 over 4, which would give us 9 over 4. And now we're going to plug into our function. We're going to plug 3 into our function, and we'll get negative 3 squared plus 3 times 3. So that'll give us negative 9 plus 9, which is 0. So we see that our minimums are 0, 0, and 3, 0. So that's where the lowest points of the graph of the function. And our max is 3 over 2, 9 over 4. So that's the highest point of the graph. And that's absolute max and min on a closed interval.